Now that UTME and WAEC are fast approaching, you cannot stay without learning about chemical reaction equilibrium. Welcome to Chemistry Mail. Today on Chemistry Mail, our business is to look at the effect of pressure on a system in equilibrium. And this is part 5 of chemical equilibrium. Make sure that you watch part 1, part 2, part 3 and part 4 so that you will have a nice and proper understanding as far as the concept of chemical equilibrium is concerned. So let's go together on this. Effect of pressure on a system that is in equilibrium. Alright. Now, remember, we have so many factors that affect a system in equilibrium, and we have looked at the effect of temperature. We've also looked at the effect of of concentration. Today, we are looking at the effect of pressure. Now, before we look at the effect of pressure, we have to make one important statement. And what is that statement? For pressure to affect a system in equilibrium, at least one of the products or the reactant must be must be a gas. So let's make that emphatic statement. Pressure can only affect a system in equilibrium if at least one of the reactants or product is a gas. If one of the reactants or one of the products is a gas, that means if a gas is not involved in the reaction, pressure will not have any effect on that system that is in equilibrium. Imagine if I have substance A, which is a solid, reacting with substance B, which is in aqueous form, to give me substance C, which is in aqueous form. Now, and this reaction is in equilibrium. Now, pressure will not have any effect on this reaction that is in equilibrium. Why? There is no gas here. This is solid, this is in aqueous solution, and this is in aqueous form also. So there is no effect of pressure here because we don't have gas among the species that are involved in the reaction. So now that we have made this particular statement so that you know the type of equilibrium reactions that pressure will have effect, now we can now look at the effect of pressure. Yeah, we have seen that the only equilibrium reaction that pressure will have effect is an equilibrium reaction that contains a gas. So that's very important, so that when someone asks you to look at the effect of of pressure on a system that is in equilibrium, the first thing you check is if the species involved in the reaction, maybe the products and the reactants, if any of them is a gas. If we don't have gases there, forget it. Pressure will not have any effect. Pressure will just walk away and say, my hand is not in this one. Yeah. So pressure can only affect a system that is in equilibrium if at least we have one gas, either as a product or as a reactant. Okay, so how will pressure now affect a system that is in equilibrium? Increasing pressure we favor the side with less moles of gas. Increasing the pressure we favor the side with with less moles of gas. Increasing the pressure we favor the side with less moles of gas, while decreasing the pressure, very simple, decreasing the pressure we favor the side with higher moles of gas. So the side that will be favored the equilibrium side that will be favored, the side that will be favored in equilibrium reaction when pressure is increased is the side that contains less moles of what? Of gas. While the side that will be favored when you decrease pressure is the side that contains higher moles of what? Of gas. Yeah. So if you increase pressure in a system that is in equilibrium, the equilibrium position will shift to the side with less moles of what? Of gases. Of gas. The same way, if you decrease pressure, the equilibrium position will shift to the side with what? Higher mole of what? Of gas. Now look at this. You know, we are going to come back to look at some equilibrium reactions. Yeah. So now let's use maybe an arbitrary reaction. Now if I have let's say I have this A is a gas, and we have 2 moles of A reacting with B, which is a gas also. And at the end of the day, it's an equilibrium reaction, and we have 4 moles of C, gas also. Okay? Now we have this reaction. This is a gas, this is a gas, this is a gas. Now, what is the total number of moles here? We have 2 moles of this gas and 1 mole of this gas, making it what? 3. Total number of moles of the gas here is what? 4, right? Now, if we increase pressure, increase in pressure, the equilibrium will shift to the side with less what? Number of moles of gas. So if we increase pressure here, how many moles of gas do we have, of gases do we have here? We have only 3. Here we have how many? 4. So which side has less moles of gas? It is this side. So if you increase pressure, the equilibrium will move towards the side with less what? Less mole of gas. But if you decrease pressure, the equilibrium will look for the side that has higher moles of gas and favor that side. So if we increase pressure here, the equilibrium will shift to the left. Why will the equilibrium shift to the left? Because the left hand side has less mole of what? Of gas. When you increase pressure, take it again, increase in pressure will favor less mole, smaller moles of gas. Increase in pressure will favor less moles of gas. Now decrease in pressure will favor higher moles. So if you increase pressure here, the equilibrium will check which side has less mole, this side. So the equilibrium will move, the position of equilibrium will start shifting to this side. That means the backward reaction will be favored. But if I decrease pressure, decrease in pressure now, decreasing the pressure will favor the side with higher moles of gases. So if you decrease pressure, where do we have higher mole of gases? It is here. So the equilibrium will shift towards this side. The position of equilibrium will shift to the right. Yeah. So the forward reaction will be favored. Do you see that now? So you must understand this. Just like these moles, they serve as volume. Just as if you are applying Boyle's law. We know that increase in pressure we reduce volume. Yeah, we decrease volume. That's why in Boyle's law we have that pressure is inversely proportional to what? To volume. So as pressure is increasing, volume is decreasing. So as pressure is increasing, volume is decreasing. So we look for side with decrease in volume. As pressure is decreasing, volume is increasing. So decrease in pressure will favor the side with higher what? Higher volume. While increase in pressure will favor the side with lower volume. So this side has lower volume, 3. That's lower moles. That's 3. This one has higher, right? Higher moles, 4. So if you decrease pressure, it will favor the one with higher mole. Now if you increase pressure, it will favor the side with what? With less moles of gases. So you can convert it to a sum. Increase in pressure will favor what? The side with what? Less moles of gases. Then decrease in pressure will favor the side with what? Higher moles of gases. So you can make it what? make it a song until it becomes part of you. So very important, these two statements are very important. That's the key to answering questions concerning what? The effect of what? Pressure on a system that is in equilibrium. When I increase pressure, volume decreases. So increase in pressure will make the reaction to move to where we have less volume or less mole. Then decrease in pressure will make the reaction to move to the side where we have higher what? Higher volume or higher moles of gas. All right. Thank you for following us till now. Remember, when we return, our business will be to start answering questions on equilibrium. Yeah, we'll start answering questions on the factors that affect a system that is in equilibrium. Thank you, and God bless you.